Hi, we are engineering brothers, and in our previous part, we have already solved the expression for our transfer function, which is x1 is by fs. And before that solution, we have got the solution for x2s by fs over here. But we have come out with one interesting similarities over here while finding out the ratio for our x2s by fs or x1s by fs. We have identified that the denominator for both this ratio is same over here. In this case, or in this current state of problem, we have got the assumption, or we can assume that the denominator is this one, which is quite naturally this two. So quite naturally you do feel that while finding out the ratio for our x2s by fs or x1s by fs, we have identified that the numerator will be different for both these cases, but the denominator will become same for both these type of consideration over here. That is why I have differentiated, or I have conducted a very important video for this part over here while finding out this analogy. So this is a very interesting part while solving or while have the ratio for our consideration. I want to remind you over here. First, we have find out our analogy for x2s by fs, which is quite naturally m1s square plus b1s plus k1, and the denominator is this whole thing. And for the next type of our transfer function, which is quite naturally the x1s by fs, we have come out as our expression as b1s by b1s plus k1 divided by denominator. So both these type of ratios, or both these different ratios, do have the common denominator for our consideration, which is this one. So after this solution, I no longer do require to find out the denominator, because we have realized, or we have assumed, or we have got the assumption that the denominator for the x1s divided by fs and x2s divided by fs is same for both the denominator over here. Only the changing factor for this type of ratios are our numerator factor over here, which is for our x2s by fs, the numerator is m1s squared plus b1s plus k1. For the same thing, while finding out the ratio for our x1s by fs, we have got the numerator as b1s plus k1. So this is the very important assumption that we have got while solving this type of analogies over here. Stay tuned with our classes, do follow our videos, and do like to share this type of considerations or this type of important insights with you that will help you to solve this type of problems over here. I want to repeat this portion once again. So first we have come out with our expression for our transfer function ratio, which is x2s by fs, which is m1s squared plus b1s plus k1 divided by our denominator. So this whole factor is our denominator. That is our problem, or our first problem over here. And for our second type of transfer function, we have got the ratio as x1s divided by fs, which is b1s plus k1 divided by the same thing as our denominator that is been shown over here. So while solving this type of two ratios, we have realized that the denominator for both this ratio, for our, whether that one is for our x2s by fs and whether for our x1s by fs, both these things, the denominator will be same for both that consideration. Only the different part for this ratio are our denominator part, which is for that x2s by fs, we have got the numerator as our m1 s squared plus b1s plus k1, and similarly for our x1s divided by fs, the numerator is quite naturally b1s plus k1 over here. So while solving this same type of problem over here, we should find out the x2s by fs. For that one, we have got the denominator, and that denominator is constant for our another ratio, which is x1s by fs. So we only find out the numerator portion that is appropriate to have that ratio, and we have realized that for both that ratios, for while considering the x2 is by fs and x1 is by fs, the denominator will be same. Okay, do like, do share our videos, and keep following our channel. Do subscribe our channel if you would like to connect with us, because you do feel that no other YouTube channel will do this type of interesting and insightful videos with you. So stay tuned with our classes, do follow our videos. So that's it. Thank you and goodbye.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.